वेलकम स्टूडेंट्स। इस क्वेश्चन आपको दिया है you have a matrix D which is a diagonal matrix containing diagonal elements as D1, D2, D3 up to Dn. So मतलब D is a diagonal matrix of order n by n whose diagonal elements are D1, D2, D3 up to Dn and all the remaining elements are zeros. And f of x is a polynomial, matrix polynomial. So आप prove करना है f of D, f of this matrix is directly a diagonal matrix which contains f of d1, f of d2, so on up to f of d. इसे प्रूव करना है. So let us start with my f of x. So f of x is a matrix polynomial. So let us assume f of x as sum a0 times I plus a1 times x plus a2 times x square plus a3 times x cube plus so on up to am times x power m. So let us assume that f of x is a mth degree matrix polynomial. So now what is f of d? F of d is nothing but a0 into I plus a1 into जहाँ x है वहाँ d सब्स्टिट्यूट करना है d plus a2 d square plus a3 d cube plus so on up to am d power n. Now we know that if a diagonal matrix is raised to any power k, so if D is a diagonal matrix whose diagonal elements are d1, d2, d3 up to d power k is a diagonal matrix with elements d1 power k, d2 power k, d3 power k, so on up to dn power k. So this is a theorem which we know. इस क्वेश्चन में इस थ्योरम को हम यूज करेंगे. So f of d is equal to a0 I plus a1 into d is diagonal matrix of d1, d2, so on up to dn plus a2 times d square. D square, we know that it is a diagonal matrix whose elements are d1 square, d2 square, so on up to dn square plus a3 times x cube, which is d cube. D cube is a diagonal matrix whose diagonal elements are d1 cube, comma d2 cube, so on up to dn cube plus so on plus am into what is d power m is nothing but a diagonal matrix whose elements are d1 power m, d2 power m, so on up to dn power m. So this is my f of d. So now what happens if I multiply this? So a0 into I is a diagonal matrix. a0 into I is a diagonal matrix whose all elements are a0, a0, a0 up to last तक a0. क्योंकि I is 1, 1, 1, diagonal 1, 1. So that is equal to diagonal of a0, 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 so on up to a0 plus a1 into diagonal of d1, d2, d3. So this a1 is a scalar. Scalar से जब matrix multiply करता हूँ, this will get multiplied with each and every element. So diagonal of AD1, AD2, AD3 up to ADN, sorry, A1DN plus diagonal of A2 into ये वाला matrix से multiply किया तो diagonal of A2 D1 square, A2 D2 square, A2 D3 square, so on up to AN DN square plus again A3 into diagonal d1 cube, d2 cube multiply किया तो you get diagonal of a3 d1 cube, a3 d1 d2 cube, so on, and lastly you get so on plus diagonal of am d1 power m, am d2 power m, so on up to am dn power n. Now all these are diagonal matrices. So what happens if I add all these matrices? Corresponding elements को add करना पड़ेगा. That's nothing but diagonal of A0 plus A1 D1 plus A2 D1 square plus A3 D1 cube, so on up to AM D1 power M. It's nothing but F of D1 f of d1 plus f of d1 comma second element क्या होगा a0 plus a1 d2 plus a2 d2 square plus a3 d2 cube up to so on am d2 power m. That is nothing but f of d2 comma next element is f of d3 up to so on f of dn. This is what is being asked to prove. So f of d is equal to a diagonal matrix whose elements are f of d1, f of d2, so on up to f of d. Hence, proved. Thank you.